Hi, good evening. My name is Sunil Kumar. Today I am going to tell you one protocol. This is very important protocol in IP in VPN technologies. The protocol name is IPsec VPN. This protocol IPsec VPN. In this video we will do lab or we will do some introduction about the IPsec protocol. First of all, IPsec it is suite of protocols. Like in IPsec protocol, there are a number of protocols work simultaneously. We can see that the first protocol is ESP, encrypted security payload, and one other protocol is authentication header. These protocols work together, and IPsec protocol is a framework that helps us to protect the data traffic on the network layer, and it provides the confidentiality. Means it's encrypting data, and nobody can expect except the sender and receiver will only able to read our data. That means it confidentiality. And another thing is integrity, that we want to make sure that nobody change the data when we are transferring the data from one location to another location, and in the middle uh, no one can modify the data and nobody can change the data. It is integrity. And one more thing over there, it is a completely features of authentication is sender and receiver will authenticate each other to make sure that we are really talking with the device we intend to. Okay, and it provide the password, we can say authentication p-shirt keys. This provide with authentication. And anti-replay is even if a packet is encrypted and authenticated, an attacker could try to capture these packets and send them again by using the sequence number. And if the sequence number is mismatched over there, and it will not send the data. It assume that the data is data duplicacy is there. And okay, now we will now one protocol like Diffie-Hellman, it provide the key and encryption. Encryption is used like earlier we used DES and 3DS. In DES, like hacker can hack very easily, like in 24 hours it can hack our password encryption key. But in advanced encryption, AES, advanced encryption standard, it will not be encrypted, and it will the hacker will not be able to hack the data. And now we will begin for the lab. Okay, we will do this lab on the on EV. Okay, please stay online. Okay, I have done all the configuration over there, but to see this I will remove all the configuration. I will wipe the configuration over there. And so it is very helpful. I will start the node again. This this the IP address over here is um, 192.168.1.1 over there. And the another is this, like node 1 FA 0 by 0 is configured 12.1, and node 2 192.168.12.2, it is configured by the FA 0 by 0 node 2. Okay, and we assume that node 2 is a ISP, and we have to be send the data. We have to be send the data across from one node, like from here to here. And in beside the ISP will don't know which type of data is going over there. And so we will start the start our lab, and we take the access of the putty. And Okay, we will do some little bit configuration, basic configuration over there. Next start. Now we will do the host name over there. Host name is one, and we'll do fa 0 by 0 in IP address 192.168.12.1.255.255.255.0. No shut. Now we have given the IP address on the interface fa 0 by 0. Now we enable over here one more table. Loopback is over here is we can set the loopback over there 10 dot 10 dot 10 dot 10 dot 255 255 dot 0. Okay, that is a loopback which I have configured on node 1. uh, Now I will create the tunnel, so we will pass the traffic from one location to another location. This IP address, tunnel IP address is 1.1.1.255, only class 8 IP we will use over there, and enter. Tunnel source will be FA 0 by 0. Tunnel destination, this IP address, this series is 192.168.23.2 to 192.168.2 23.3. Okay, we will use this IP address scheme on node 2 and node 1. Like you can see that FA 1 by 0 or node 2, it will use 23.2, and another node 3, it will be use 23.3. Okay, let's begin with the putty, and we will start our configuration over there. And tunnel, we define tunnel destination over there. Tunnel destination is actually tunnel destination is 20.3. We'll put this 120.3, enter. Now you can see that the tunnel will up in next couple of minutes. Now we save the configuration. Okay, and first of all we configure over there a one protocol. This protocol is work on underlay protocol, and this protocol is like one. This protocol is underlay. We will do EIGRP protocol over there, and we also defined 10.1.1.1.1. Okay, this protocol we define, and now we can check the route. Actually same IP scheme I have given this in node 2 and node 3. Okay, now the main task we will do over here is IPsec VPN tunnel. We will create the IPsec VPN tunnel. IPsec VPN tunnel will secure the data. If actually we can now we have built the tunnel, but IPsec tunnel will secure the data, and it provide the encapsulation. It decrypt the data over there. So um, okay, we will do the configuration, and we'll check here show IP section EIGRP. Okay, we have enabled over there EIGRP protocol. We have enabled there. You can ping 3.3.3.3. We are not able to ping. Okay, okay, what happened over there? Everything seems good. Tunnel down. Okay. First of all, we have to be check only underlay network. After that, we will start going to be outdoor network, overlay network. I don't know. Tunnel is not getting up. We can check our show IP in tunnel. It is disable show IP int brief. Tunnel is still down. Okay, maybe under protocol is down. EHIP protocol is down. So we will do this network 0.0.0. Okay, let's see what happened. Okay, our neighborship is up. Tunnel. Oh, our tunnel is also up. Now we will check our underlay network till now. We can see that data traffic is going, but this data traffic is going from node 2, but this data traffic is not encrypted. We have main target. We have to do IPsec VPN tunnel. To we can with the help of this we can encrypt the data, encrypt or decrypt the traffic over there. And so I will check you. This is a clear text, and okay, now I'm going to be sniff, or I'm going to be analyze the data traffic. Okay, first of all, we make a ping over there. Ping 3.3.3.3. Enter. Now you can see this no interruption over there. Data is going through one direction to another direction. It is a clear text format. Now we will see this. There is no authentication header. There is no encapsulated security payload over there. So now we will check, and we will do uh, encapsulate. We will do encapsulate the data. Okay, start. First of all, we have to define the phase one. In phase one, we will do first of all crypto IC cam policy 10. Okay, and after that we'll provide encryption AES, and then hash algorithm is MD5. We can define anything. Okay, well, sure, but we define MD5. And group ID we can define one two number of group IDs over there, but recommended by is two. Okay, and p shared key, we can define the p shared key over there. P shared key is this. Now it is defined with the p shared key. Now all the parameter we have defined over there. This parameter is phase one parameter. Okay, and this all the parameter we will define in a single protocol. All the parameter like encryption, hash algorithm, group authentication, all parameter will go via IceCamp protocol. Okay, and now we will define one more command over there. Crypted IceCamp key 0 Cisco ID, we can define Cisco address. Now we have to be define the underlay network which is node 3 f 0 by 0. Okay, and now we will define one access list over there. The traffic extended access list we are defining over there, and permit 1.0.0. This is the source, and subnet mask, it is a wildcard mask, and Destination tunnel is 255 255 255. Enter. Okay, we don't define anything. Missed something. Maybe we missed IP address. Okay, now we will define the crypto. Now this configuration is this configuration I'm going to do. This configuration is based upon phase 2. Phase 1 we have completed, and now we are doing phase 1. Okay, crypto map ABC1. ABC we can define anything, any name. 10 we will discuss earlier, 10, and IPsec ISCAN, and we will define the peer. Which peer we have, like 192.168.23.2. This underlay network is there, sorry, 3. Under network is 3. Fine. Now set transform set over there. Transform set is, we can find any name we can define. Not there. One is also not there. uh, Set any name. Hmm, it's not getting. I don't know what happened over there. Okay, we will define IPsec crypto. Okay, back crypto IPsec transform set ABC. We can define any name over there, and after that we will define this 3D as define further. It is ESP MD5H. Okay, set pair we define already, and set set transform set peer. Okay, it is not getting. Okay, crypto map. I think it is ABC 110 IPsec ice camp. Enter. Set peer 192.168.23.3. This is the peer. Earlier, now set transform set ABC earlier we have created over there. Match. This match is our access list. Then exit, or we have to be defined on interface already. Sorry, and then crypto map we have defined over there ABC1. Okay, now you can see this crypto IceCamp is on. We have defined phase 1 and phase 2 configuration. Okay, I will see you all the configuration. So run section crypto. You can see this. First of all, we define crypto IceCamp policy 10. After that, encryption AS hash algorithm authentication. Then group 2. Then we have defined this our peer device authentication, define HMAC or ESP authentication header. Now this is the phase 2 configuration, crypto map, set peer, transfer set. Okay, now we can check after ping. Okay, ping ping from 192 1 dot. Now we will define crypto map ABC. We will match the cryptography on the interface, and we will wait for the okay. ISCAM policy is up now. Now we will ping from 3.3.3.3 source 1.1.1.1 because we have make the tunnel from 1 dot to 3 dot and ping. Now we have received the ping. Now we check this thing on Wireshark, and first of all ISCAM identity is there, then quick mode, and we will again ping the same thing. Now repeat only one. You can check over there. Packet is encrypted. ESP. Check. Encapsulated security payload. Packet is now encrypted to the one through the end to end. Now we will check one more thing over there. I will show you the all the commands, which is show section crypto. This is router 1 command. Okay, this is the router 1 command. You can show over there. The router 1 command is this. First of all, phase 1 is there, encryption, hash algorithm, authentication, p-shot key, group number. After that, we become crypto ISCAM key, security, address, peer address we have defined, and 3DS, HMAC, defined mode, tunnel mode. Then phase 2 configuration is this. Okay, now we have now our packet is encapsulated, but we have checked the simple ping over there. This ping is from the router, that is not from the source. Now we will check over there. This ping is not encapsulated because we have encrypted our tunnel with the help of IPsec. Okay, I will see you the configuration of node 3 because node 3 is already configured over there. You can see show run, show crypto. Oh, sorry. Show crypto. Only we have changed the IP address schema. This IP address is node 1 IP address, underlay IP address. Okay, only IP address change. You have to be take care of each and everything. ABC1, this thing, this password, you have to be take care of. Now, how can we check this IPsec tunnels like iScam? No, show crypto iScam SA. We can check. Okay, tunnel source and destination is there. State is ideal. Connection ID. So active state. Each and everything we can check. This is we check only phase 1. Now we check IP phase 2. IPsec SAS. Okay, check. We have ping 5 packets. 5 packet is encapsulated, 5 packet encrypted, and digested 5 packet. Okay, okay, you can check one more packet over there. Ping. Okay, 1 packet, and you can check IPsec. 1 packet. Earlier 5 packet is there. Now it's 6 packet is there. Okay, you can check. Our tunnel is encrypted. IPsec encrypted. Okay, thank you guys. You will see this video if there is any doubt, and you can tell me. Okay, thank you so much.